In this problem, the function we're given is the temperature, not the rate of change of the temperature, but the temperature itself, and we're told that it's everywhere increasing over the given time interval. And we're also told that it's differentiable. In A, what's asked is the instantaneous rate of change of the temperature. So basically they want to know dH, which is a function of time, with respect to t, and they want that evaluated at t equals 10. Well, we don't know h as a function of time, we just know its values at certain specific points in time. And so the best way to estimate dH dt at t equals 10, right here, sort of midway between the 8 and the 12 value, if you will, is to find how much h has changed from 8 to 12 minutes, divide by the difference between 8 and 12 minutes, and see what we get for an approximation of the slope dH dt. So we'll write 80 minus 73 over 12 minus 8. We get a positive 7/4, and that's a rate of change of temperature, so the units must be degrees centigrade or degrees Celsius per minute. B is asking for the average temperature. We know that the average temperature of a function, again, don't confuse it with the average rate of change, the average temperature of a function over an interval a to b is 1 over b minus a times the integral from a to b of whatever that function was, integrated with respect to the variable that the function is given as. So in our case, this becomes 1 over 16 times 0 to 16 h of t dt. Now they ask us to use a left Riemann sum to estimate this value. The left Riemann sum just gives us, again, this is an approximation. We can pull the width of each of the Riemann rectangles. We can pull that out of our sum because the widths in this particular case are all the same. We just add 65 plus 68 plus 73 plus 80. Notice that in every case we take the value of the function, the height of the function, at the leftmost edge of each of the 4 rectangles, at each of the 4 subintervals. And putting all this together, we get 286 over 4. Write that out. And that equals 71.5 degrees Celsius. Now, have we overestimated or underestimated? Well, we used left Riemann sums. That much we know. But the other important fact is that they told us that this function is constantly increasing. And so that means if we were to sketch our function an increasing function, something like this, then because we used left Riemann sums, in every case we say that left Riemann sums are underestimating an increasing function. A left Riemann sums underestimate the integral of a function over an interval where the function is increasing. And since our average simply takes that estimate and divides by a width, therefore we know, because the average is just an estimate over 16, we therefore know that our average is an underestimate. All right. Finally, part D asks us whether the data is consistent with the concept that the temperature is increasing at an increasing rate. H of t, is it increasing at an increasing rate? Let's be careful about what that language means. We already knew that h of t was increasing. That was given at the beginning of the problem. Okay? What they're asking is the data consistent with this being greater than 0 over the interval? That's the question. Is it consistent with dh dt being greater than 0 over the interval? Is there anything about the data that would contradict that? Well, in order to figure that, we need to understand how dh dt is changing over the interval. So if we were to estimate dh dt based on the first two pieces of data, we'd get 68 minus 65 over 4 minus 0, or in other words, 3/4. Similarly, for the remaining estimates, this was useful over the 0 to 4 interval. For the next interval, that 4 to 8 interval, we would get a rate of change of h of 5/4, and then 7/4, and lastly 10/4. So again, I know this is a little bit crowded, but this is our estimate of dh dt in the 0 to 4 interval. Here the 4 to 8, here the 8 to 12, and here the 12 to 16 interval. And what we have is that dh dt continues to get larger and larger. And so we just say that estimates of dh dt continue to increase over time, and therefore the data is consistent with the hypothesis.